welcome to this breakfast seminar. And yeah, just a couple of words about ITRL. ITRL is an integrated transport research lab founded by three strategic partners, ETH, Scania, and Ericsson. And it studies sustainability transitions in the context of transportation. How do they happen? And what is important here that it's not only about the technical aspects, but ITRL thinks that a multidisciplinary and multi-level approach to sustainability transport solutions is really important, and that's why it focuses on all aspects, on business models, on regulation, on infrastructure, on efficient transport concepts as well. Our guest today is Assistant Professor Emrah Karakaya. He is a newly appointed professor at Department of Industrial Economics and Management, and he is an assistant professor in sustainable business models and industrial dynamics. So that his expertise fits this research problem really well. So yeah, he has been really successful in publishing high impact research, and being in his first year as an assistant professor, he already has more than 250 Google Scholar citations, which is highly unusual. So welcome, please.
Thank you, Maxim, for the nice presentation. I have chosen such a big title, but do you think I will be able to answer this question?
We'll see.
Let's see. So that's why I changed the title to Diffusion of Innovations and Technological Innovation Systems. Have you heard about these frameworks? A few has heard, but not everybody. And I think the idea today, for me at least, to bring insights from these two theoretical perspectives. Maybe you can use these perspectives in your empirical cases, because I know each of you can have a different empirical focus. Maybe you work with transportation, or maybe you have a different interest, or you have a different case to study in the future. So the idea is that after we finish this lecture, you should be able to differentiate between these perspectives, as well as what we can learn from that. Do you know where this photo comes from? Can you guess?
Germany?
Yes. How do you know?
Because of the rooftop solar.
Exactly, yeah. And why do you think I put this photo?
I think it's maybe a clear example of how a particular technology has been spread and adopted.
Yes, exactly. Yeah. Actually, there are many reasons, and one of them is this reason. So I stayed in this company here. This is a solar company, local company. I stayed and worked in the company as a researcher to conduct one part of my PhD thesis for 3 months, from 2012 to 2013. And also I did a lot of observations, and this is also a very good picture, which I didn't take, is that what you see here, the solar company itself has solar photovoltaic rooftop applications, and immediately you see that some of the neighbors also have. So we don't have actually an evidence for a causation, but we will talk about this kind of diffusion cases, why this happens the way it happens. So just to give you some background about how I collected data, which I will try to make some references when I go through different theoretical aspects that I want to introduce. So it was from 2012 to 2013. It's based on a case of a company which I showed, and of course that time I was much younger than today, and it included some interviews, like semi-structured, and lots of observation, and a lot of internal data of the company. And this is the second case. If you have read the abstract, you can guess, but what do you think is this, where this place comes from, or where is this taken? This one I took myself, the picture. It's from the Luglio. I don't know if I pronounce correctly. Luglio. And this is, what's that?
SSOA.
Exactly, yeah. And have you heard about them in recent years, about some kind of transitions they want to have?
No, not that much.
To hydrogen, right?
Exactly, yeah. So one of the interesting things about them, I have been studying not only the company but the overall the mining and metal industry for a year now. I have some papers in pipeline, and one of the focus, as you said, is hydrogen-based technology. The idea is that this industry heavily based on coal, and coal produced out of carbon dioxide. So if they can shift from coal to hydrogen, which is very ambitious, they can also cut almost all carbon dioxide emissions, CO2 emissions. And I will also give maybe a few examples about how this relates to two theoretical perspectives that I would like to talk about. So this is the first theoretical perspective. It's, I think, quite easy to understand, and you can think about your empirical cases in mind. But if you really want to go in depth, this is mainly developed by Everett Rogers, and he has published many books and, of course, many articles. And he has a PhD in sociology. It also explains what kind of perspective it has. So as Maxim said also, it's not only about technology, and maybe it's not only about business models or institutions, it's also about sociological aspects if you want a transition happen. So I can imagine you may define what an innovation is, but for the sake of a unity, I would like to define as Rogers does. So innovation is actually anything. It can be perceived as new. And I think the key term here is the perception, which will come back to that. And who can be adopter or unit of adoption? Because it's not always the case. Maybe if you think about electric cars, an individual is adopting that innovation. But if you think about a solar panel, the adopter could be a household or a school. So actually, in the broader terms, adopters could be individuals, like households, or governments. And we can think that anything new that's perceived in that way could be an innovation. So perhaps some of you have a background in natural sciences, and it's very, I think, important to understand actually what diffusion is, and what you do when you put an ink in a water, it diffuses in the water, which is very simple. And also some sociologists, they believe a similar process happens in society. So diffusion in our context is a process at which innovation is diffused among the different people. So do you have WhatsApp? Everybody has, yeah. Do you know why do you have it? Or do you remember why did you adopt it? Yes. What do you?
Some friends had it.
Exactly. And that's a very typical example, and it was the same for me. Not that because I perceive it as something really good, but because of the peer effects. And what happened is that in a short time, this technology has been diffused from like person to person, and then maybe you will see the curves now. So the idea is that, which is interesting, because in many cases, even you can think that the society cannot really be modeled or cannot be predicted easily, but still we can see in many cases this kind of S curves, which we will also observe when we put ink into water. That's also quite exciting, but also it's not always the case. Of course, sometimes it can go down. These are the examples of good, successful innovations. And also in today's world we receive so many innovations in our lives. So one innovation comes and the other comes and the other comes. Maybe you can think about iPhones, and then perhaps the idea for the change agents behind these innovations to reach this 100%. And then you can also identify different types of adopters. Maybe the innovations, the adopters who adopt first, we can name them innovators. And the idea is that the curve here you see is like a cumulative adoption. If you take the derivative of it, you can see the adoption rate. And also it's important for you when you maybe think about the case when it comes to transportation, it's important in which phase you are in, so that maybe you can develop different methods to attract different kind of adopters. So this is what theory says, and actually that's what have we experienced in practice as well. And if you look at these different three examples, which I guess most of you have, like WhatsApp, Facebook, and Twitter, in just a few years after they have been launched, they reached these S-curves. Of course, we don't know yet if it will reach their 100%. It's also sometimes difficult to define what is 100%, because some innovations can be adopted twice, and some innovations cannot be adopted at all by some individuals if they don't have the standard setup to adopt it. So what makes innovations adopted by individuals or any kind of unit of adoption? So the Rogers identify 5 different characteristics based on a different empirical cases, and this has been also confirmed in my studies. So the first thing we should look at it. What is the advantage that the innovation brings? So if I'm adopting, for example, an electric car, as an adopter I can think what is the advantage in relation to other options. So, and the key thing is that you can think that if you launch the best electric car possible, you can think, okay, it will be adopted by people who can afford it. But the key thing is that it is not your perception that decides that person will adopt it. It's the perception of the adopters. So the key thing is here is that sometimes you can have the innovations that really has good advantages among others in compared to other options. But if it's not perceived good, it will not be adopted. And the compatibility, of course, it's also how this innovation you want to bring to the system is compatible with the existing values and also the system characteristics and also the infrastructure. So, what do you think whether a CVish is compatible with, let's say, neighboring countries?
Probably not.
Yeah, why not?
Legislative framework, probably.
Yes, it could be. Or maybe with the other
Culture
kind
as
of
well. Culture
yes.
as well. The willingness to share.
Yes. Yeah. So it should be very important that if you want an innovation to be diffused, you should take care of whether they are compatible. It's not only like the factual things. Maybe, of course, like regulations or institutions can make this compatibility easier. But if it comes to maybe existing values or past experiences, then the perception also comes to the picture. So you should also take care of how people perceive it, not how good the innovation is. And the third dimension is the complexity. Overall, the less complex it is, the better it should be. And do you think that electric cars are perceived as like complex? for potential adopters? Not so much. Maybe it depends also the context you're studying, like which country and which also maybe what kind of adopters are they, and what kind of solution and how do you package it. So it's also again the perception. That's why it comes to the picture that you should really, in this kind of studies, one of the good way to assess this perception is to do case studies and doing interviews and trying to explore how they really perceive it. And another important aspect is triability. It means whether an innovation may be experimented with some basis. For example, this is the case I did also. Do you think solar systems can be trialable?
It depends on how easy is it to fix them.
Yes, yeah. So in this context of a household, and usually if you have this kind of systems, maybe it costs like 20,000 euros or 30,000 euros, depends on the specifications. And actually there is no easy way of trying it, because once you put it on your rooftop, you are supposed to have it unless you want to lose your money. So that's why actually it makes this kind of innovation to diffuse so slowly in compared to WhatsApp, because WhatsApp you can just install and delete it, so you can try. There's a aspect of triability, and observability is also of course very important. The more observable the innovations, the better it is for diffusion. So what do you think about which innovation is more observable? Yes?
What do you mean with results? I mean, for example, with solar panels, the solar panels are very visible, but the reliability of the electric loads aren't. It's not visible.
What is not so visible?
Like how much you can actually rely on them for your electric needs.
Yes, yeah, that's a very good point. Yeah. So actually, there is like the results depends on maybe the context. In the case of like Germany, when you have these panels, you usually get an estimation about how much you can generate in the next 10 years, because they can forecast the weather conditions and they know the angle of your everything you will have. So you can actually predict the results that you will get out of this. And maybe in some other countries it's not maybe that predictable or observable. But also the innovation itself is in some cases more observable, not only the results. Like for example, if I just go around, I can say which households have these innovations, just looking at their rooftops. But when it comes to some other innovations, like maybe Switch, I cannot say now who has it. Or if you think about like televisions, I don't know actually who has television at home. And if the innovation and also the results are observable, it makes it much easier. That's why in many cases the companies put open door days to make it more observable and make them understand what the results are. So you can think about these 5 factors in terms of maybe transportation and how you can accelerate the transitions in transportation. And of course there are more factors. It's not only that 5 factors that you should take care of. The communication. Sometimes the communication is based on peer-to-peer. Sometimes you use mass media. And the social system you're in, and the boundaries and the change agents. For example, in the case of solar PV systems that I did this study in Germany, a lot of communications were peer-to-peer. There were no mass media done by the company. Of course, it was in the newspapers in different aspects. And there's of course some change agents involved. this picture that I took, I think it represents the whole story in one photo. So I took it during a solar walk. That means Thomas, he's the head of this small company that I shopped. And what do you think these people are looking at him?
Potential customers?
Exactly, yeah. So what he does is that he meets with anybody who is interested in. They are, of course, potential customers, but they don't have to be a customer. And it's like scheduled meetings every month, once a day, once a month, and he makes a excursion in the town for 3 hours, and he shows all the possible options that they could have, and he did in the past, and they can also have interaction, and also he takes these people back to his company, at which they can have a lunch and at which they can experiment solar systems, seeing it, how they produce it, how electricity is generated. Of course, this kind of a change agent, which is Thomas, he increase the likelihood of these potential people, because then after these excursions, they perceive it much better than they used to think, perhaps, and also it creates more knowledge about the technical and all the possible aspects, especially in such innovation is not very triable. They cannot try it, so at least these kind of excursions helps them to understand better.
Is he employed by the municipality or?
Sorry?
Is he employed by the municipality?
No, he's a private company, and I can maybe show you how the company looks like. Maybe. So this is the company. So he built maybe this company, or this was built 2004. He was doing similar work before with solar thermals, and it's a family company. So he has also his partner helping him, and he has 7 kids. They're also all around. They have also 5-6 employees, and I joined them also for a while. Of course, he is for profit. But when you talk to him and to my observations, it also has a lot of this passion to spread this technology. And he's a local of this region, which I will show some examples from what people said about him. So they speak a very strong dialect in this region as well, which makes this communication much better between him and the potential adopters. So this is because I told in the beginning that I will show 2 different perspectives, and the first one was the division of innovations, and the second part is technological innovation systems, maybe which is related to this. I saw this word somewhere, systems, transport systems. So, of course, systems can be defined differently. Maybe when you talk about sustainable transport systems, it may be the case that you talk more about the technical side, or not, I don't know. But in our case, a technological innovation system is a socio-technical system, which means it has both dimensions, technical and social. And the idea is that the system is focused on the development of an innovation as well as the diffusion. And it is an analytical construct, so it doesn't happen. You cannot really empirically see these systems. You cannot see that, go to the street and you cannot say, okay, this is a system, I'm looking at it. It's just a construct for researchers and policymakers to help them understand what's happening in the reality. And the key thing is that it has structural elements and systemic functions. So this is actually work done by Swedish researchers 10 years ago now, and it has evolved a lot, and it become an important tool for researchers and policymakers to assess whether you have the necessary innovation system to foster the innovation you want to develop. So it's actually very practical oriented, but it has also its theoretical rootings in evolutionary economics. But we will just talk about this practical version. So the idea is that if you want to understand whether an innovation system, take the example of electric cars or any other kind of transportation, you should first define your system very well. So what is the boundaries? You can focus on like a local region. You can just say, I'm just focused on Stockholm, and I want to focus on a specific technology. Or you can focus on a more broader technology that can be involve a lot of technologies. So once you define your innovation system with boundaries, which is very important, then because then somebody else can compare it with others, then you should look at the actors, networks, institutions, which we call them as like structural elements. And then the idea is that when you have the necessary actors, networks, and institutions developed, they function like a system which which develop knowledge, which mobilize the resources, which form the market, and also influence the direction of search and the beliefs in the system, and some other functions. And the idea is that when you identify these functions, you can assess them. Does it really function in your system? Does it make sense to you? Yeah.
So do you mean which actors or networks contribute to each of the functions? Or
If you can
like
do that,
what should we be asking ourselves?
In practice, it's very difficult to match. It's a very good question because actually the unit of analysis is the system that you look whether the market is formed. If market is formed, maybe of course you can tell some actors are more important to develop it, maybe some others not. But it's really difficult, I think, to find these links in between structural elements and functions. And then when you have mapped this empirically, so you assess is there something missing with this? For example, if do we have enough entrepreneurs? Does the market has developed or not? And then if not, then you look at for the blocking mechanisms, and then perhaps you should change some policy measures that can affect the actors or the system functions. Then you can develop a better innovation system. This is very abstract, I know, but it helps actually to understand what may be the problem in the system. If the transition doesn't happen, that you waited for a long time.
Yeah.
So what kind of actors you can find? This list can grow actually, of course, but the typical actors in innovation systems are the companies, like of course small and large size companies, institutions, institutes, universities, and all kind of other actors that you can think of. Depends on the case, like the civil society, governmental agencies, and so on. And also this is the institutional aspect, because there are some set of rules in the system that may be defined by formal and informal institutions, better said, the hard and soft institutions. The hard ones are the rules, laws, regulations. Of course, if you are the government, if you are a policymaker, you can change some regulations and change the innovation system to function in a better way, so your innovation is diffused. Or you can have a look at the customs and habits in the system. And of course, there's something important like networks, formal and informal networks, which should be also mapped to understand what's going on. So you can think about like these examples, how they relate to different actors and institutions and networks, and how it changes depending on the context. Because if you take the electric car and put in maybe South America or China, or if you put it in another context, you can deal with different actors. And of course, technological innovation systems can have an international depth because we are not isolated. But for the empirical reasons and for data collection, you should delineate your context so that you can understand something in your case. So if you go back to the case of Thomas Hartmann and his company, of course it is here much easier to understand the actors and networks because it's much smaller. Maybe I will not go so in depth with this picture, but just to give even in such a small network of companies, you can see a lot of different dimensions. Like there's the company on the top, and then they create value by creating projects to the adopters, and adopters are also linked to electricity utilities. And there is regulations that guide feed-in tariff, which I will talk about later. There is actually a very complex picture that you should really understand to assess whether the innovation system in that context is good or not. So something interesting, because I maybe remember I told like there are formal and informal networks. So in this case, something worth mentioning is I did interviews and I asked people like why do you install this? Because maybe your neighbor doesn't, but you do, or in other parts of Germany they don't do, but you do. So what is the difference with you? And in some answers, it came out as well that such simple answers, and it was repeated many times. The reason that they adopted this innovation was just because they knew Thomas Hartmann and they trusted him. So it's not only about regulations and formal relationships or technology or business models. It comes also to the picture of informal networks. So going back to this picture and the functions, maybe you want to understand better these functions. So I listed them here, and we can think also like not only about actors, because I asked that question, like what kind of actors we can have. And maybe we can also understand why maybe electric cars has not been developed so far by looking into different functions. Do you have any questions? So going back to the case of Thomas Hartmann, so one of the functions is here knowledge development and market formation. Yeah, here. So I want to just pick some examples to give more empirical examples how these things happened in this case. So it was, so the company goes back to 1994, but as I said before, it was actually like a solar thermal company. The difference between thermal and photovoltaics is that with solar thermal you produce heat, you can warm up your water, and with solar photovoltaics you generate electricity. And then after some experimentation and also creating some associations, creating some knowledge, and doing the first project, and of course with the support of the feed-in tariff, which I will show in the next slide, they turn into like a company that focus more on solar photovoltaics. So the knowledge development and market formation in this case took, at least for this small town, like more than 10 years. And of course it was accelerated by the resources mobilization, in this case, which is maybe more important to talk about financial resources. Of course, this is a very expensive innovation to adopt, and you need to face high upfront costs. So this is just an example of how this feed-in tariff change I think somebody has seen the difference between here. So I think maybe you think there must be something wrong here. Or do you think that something is wrong in the slide? No. The price is wrong. Or what is interesting in the...
Isn't the source from the grid more cheaper?
Yes, exactly. So that was the idea of the feed-in tariff. And of course these numbers are kind of random, but that was more or less the same ratio. And of course, this gap has been reduced because the innovation become cheaper for the new adopters. But the idea is that by giving this financial help, the adopters who adopted these systems, they can, by using this system, they can pay their installation costs back. Is it clear, Maxim? Because it's very costly innovation in the beginning, and then the government didn't give them like subsidies directly, but every time they sell the electricity to the grid, they have these agreements for 10 years or 20 years. They say, okay, the government or the system will buy the electricity for next 10 years with this price. And of course, maybe this price can change during time, but you know that at least you are likely to make some profits by having these systems. Of course, this helps also this company to maybe focus on more solar PV systems. And going back to the diffusion curves, again we see S curves. So these are the feed-in tariff. They're implemented. Actually, they really make they help the market form in a better way. And there was also an interesting case here, which I will tell after I explain this. So there's of course different market segments. When we talk about households, they are usually in the small segment, but there are also some maybe more commercial adopters, like schools or maybe a church with a big roof or a big space in the garden, or much larger like solar farms. But in overall, in all segments, we have similar like a S-curve. One can think that because this is like per year, which is diffusion rate, so which can think maybe it's going down, but yeah, I don't know the numbers for the rest. But the interesting thing is here, like there was a grid parity achievement, which means that which in like a long, to make the long definition short, you were, by having these systems, you can produce the electricity much cheaper than buying the electricity from the grid. So it was like a milestone, because then actually automatically by having this system, you will produce, for example, your electricity with 15 cents per kilowatt hour, and then if you want to buy it, it's like 20 cents. So that should actually make the case that actually here you should expect, oh, everything should grow because technology became so mature because it's financially better off, but it didn't happen. And that's why actually this kind of theories such as diffusion of innovations explains a lot. It's not only about this financial situation, financial aspects or technological maturity.
And what was the reason?
That's
For
the
it going
yeah. So I also make this similar analysis in the local level. Of course, I think one of the reasons is that we are reaching the maximum capacity. This could be one reason, because not everybody has a potential to put such systems for rooftops. And the second reason could be because we don't also know, we cannot really calculate exactly how much we can put solar systems, because you can put also on them on facades. Maybe you can calculate the roof areas about you can put on your garage. That can be one critical factor to understand, to really understand whether we have reached this maximum capacity in Germany. And the second reason could be that the targets were quite achieved, because the national there was national targets to achieve in terms of share of solar electricity production nationwide, and it was going very well. And somehow this feed-in tariff has been reduced, and I think there was not a good perception in the society anymore that it's really better off. But actually, technically, it was better off. It was better in financial terms, but it was not in the social accepted anymore as it was before. That could be like a social reason. And going back to the case from SSAB, so they try to shift from coal to hydrogen when they reduce iron to produce steel. And the thing is that there was lots of guidance for research, which is one of the functions that we talk about. First of all, the Swedish government set goals to cut industrial CO2 emissions by 2045. This gives a clear signal to this kind of industries because iron and steel industry counts for 1/3 of global industrial emissions, and so this is a good signal from the governments to give to such industries that okay, we want to cut this. Otherwise, we should maybe look for other places to survive. And so you can see from headlines that Sweden aims to become the first place to be a zero carbon steel production. And also there was lots of supports like from agencies such as Swedish Energy Agency. So this gives actually a good direction and search guidance for companies such as SSAB, LKAB and Vattenfall, so they can join forces to push for this technology. Of course, the technology is in a very experimental stage. I will not go into details of it, but you can think about are there really entrepreneurs? Because one of the functions we need to expect from innovation system that you need entrepreneurial experimentation. Do you think there are entrepreneurs in this sector, iron and steel industry? Because what usually imagine about entrepreneurs is like maybe entrepreneurs such as like small companies, and they maybe work in garages, there are startups. Actually there are entrepreneurs, but the entrepreneurs are the incumbent companies here. So they experiment actually themselves, because it's very difficult for a new entrants to join this industry. You cannot just open a small company and go and dig some iron in your backyard. So that's why actually that's difficult for new entrants. But still there are some entrepreneurs, which are the incumbent companies, which is an interesting case. And then they actually already planned for this kind of like almost 30-year plan to make some pilot plans and then demonstration plans. And of course, it's a quote from one of the interviews. These companies, they need a lot of support from the financially, otherwise they cannot experiment such a high risk technology. So that is one of the last slides. So to just sum up, like why they are important to look at these functions, because we talk about these actors and institutions and what was the other one? Actors, institutions, and
Networks.
Networks, yeah. But it's actually because the overall assumption before was that okay, we just look at actors, networks, and institutions, and you can understand quite a lot. But then they have developed these. The researchers that talk about these different kind of functions. If you don't have these functions in an innovation system, you cannot really develop an innovation that is mature enough to be adopted. So that's all, of course, important. If you want to have a system perspective, you can maybe use this theoretical framework. So I promised you that you will understand the difference between these two different perspectives. And so what do you think about this? What is the main difference between these two different theoretical perspectives?
One is kind of planned, the other is a bit more biological, so it happens naturally.
That's actually a very good observation. Yeah, I didn't think about that. You think diffusion of innovation is more natural?
Yeah.
Yeah, and this sounds like more planned, and you can really fix things, and
Yeah.
yeah, that's actually that. Yeah, I might agree with that, yeah, but I didn't think about this before. What else?
Maybe the former one is more related to the market, the customers. You want to see how they match each other, and the second one you emphasis more on the system itself, the technology,
Yeah.
the aspect.
Yeah, exactly. Yeah, actually, that's one of the basic differences. Here, you look at the demand side, or more at the adopter level, and how they perceive it. So actually, your unit of analysis is usually like the adoption level, and you're in the market and try to understand how people perceive it. So it's more like a sociological perspective, and this has like a broader systemic perspective, looking at the supply side. So like a demand side versus supply side, we can tell in short. And yes.
I'm curious to know actually, in relation to sustainability transitions, these both theories have been criticized as technocentric, despite the fact that they include some social factors.
Yes.
So I'm wondering, how are you talking about these in the context of sustainability transition?
Yeah.
Because they are very different in unit of analysis
Yes.
and very different in the way they analyze the social context.
Exactly. Yeah, that's a very key question. So actually, like this is when you use diffusion of innovation theory. I think this is kind of more established. We can call it as a theory. It has been tested in several cases. But technological innovation system is just maybe like a emerging theory, and some people believe it's not a theory at all, and it may be falsified. And what I would suggest, if you want to go for technological innovation system, maybe using some complementary perspectives, such as a multi-level perspective, like at which you define also like the technological niches, regime, and landscape. Actually, that's what I did in my case study. I didn't want to go too much into detail in this, not to bring too many concepts. So I agree with you. Actually, they cannot alone explain the big questions I put on the title. And I don't know also if we will have like we will be able to develop such a comprehensive theories that explains these transitions in all aspects. Does this reply your question?
Well, there are some.
Or do you have any
competing-
suggestions? Yeah.
Because as far as I have seen, technological innovation systems focus on functions of innovations.
Yeah.
So then they look at the different technological functions and how they spread across society. Diffusion of innovation looks at more adopters
Yes.
and more characteristics of like market users and early stage development and so on. Whereas like multi-level perspective looks of changes over time in socioeconomic context
Yes.
or socio-technical context, so they all differ in terms of theoretical lenses.
Yes. Exactly.
So I don't know how you have used them together
Okay. Yeah.
because they have competing theories
Yes.
in a way.
Competing assumptions behind it as well.
Exactly,
Yeah.
and particularly a recent article from Giels
Yeah.
and a few from the research center in the UK, they came up with analysis of all these theories and kind of differentiated between why they are now limited in giving perspectives of socio-technical transitions. So that's why I'm curious to know.
Yeah, I do agree. There are some attempts like actually this has been not really linked to each other, but I know some researchers they try to link this because of course this is a little bit it can be superficial if you want to really link them because they have different assumptions behind. So it means that you actually change their meaning when they try to link them. But there are more attempts that they try to merge technological innovation systems with a multi-level perspective. It has been also criticized a lot for the same reasons. That's why actually like you should be very careful about limitations of this every perspective. And also, yeah, you should be careful when you try to link them. And of course, you can end up with your own definitions and own assumptions. Yeah. But I have the same, let's say, critic and problem when I try to combine them in different studies.
But you did not use them in the same study in that sense. I mean, they're in the same presentation as showing exactly the different perspectives, but they were not used in the same study in that sense.
Yeah, they definitely bring different results.
Yes, but they are not used. They were not used in the same study.
Yeah,
For that reason, there is no contradiction.
But actually, it can be used yeah.
Well, some people call for theoretical pluralism when
Yeah,
you
okay,
think
yeah.
about empirical problems, so you have to use even contradicting theories to get a better understanding of various aspects. And but it's it's a big discussion.
Any other questions?
I have a short question.
Mm-hmm.
How can you identify innovators and early adopters?
Mhm.
How do you identify them? How can we look for them, for instance, in terms of transportation system? How can we find them to make the transition happen?
Before it happens.
Yes. I mean, in order to facilitate it happening.
Mm-hmm.
Are there studies on their kind of differentiating characteristics? Do they have something special about them? What helps to find them, identify?
Mm-hmm. I have not studied this, but I can just say my, let's say, general knowledge. Usually, there are some studies, they look at the social networks, try to identify who is in the core of the social network. And looking at their social network structure, maybe the people who stays in the core of the network may be more influential, or they can be more transmittable, and they transmit innovations. But otherwise, how can you identify them before the innovation is in the market? Do you have any answers for this? This is a very big question, I think, but there must be some maybe studies on this, maybe some others know.
Yeah, if you come across something like that, let us know.
Yeah, it's a
Please let us
good
know.
area of study.
And just a comment on that, that's like I have some previous experience from the commercial sector, and I think that the role of startup companies and entrepreneurs and innovators is also to find those early adopters. I mean, that's how they survive. I mean, with a new innovation and a new product or service taken to the market, I mean, they survive by finding those early adopters. So I think that might also be one kind of function in this technology system, or is it innovation system, that the startups are companies that can find and survive by finding those early adopters and spin from that. So that's maybe a function.
When listening, I remember answer for this. There is this lead market model, because a lot of companies, they have these innovations they want to put and test somewhere, and they don't choose like individuals, but they choose a region to focus on. And to do that, they have this lead market hypothesis, and they have this also 5 characteristics. So they look different cross regions to assess based on like the market structure advantage, demand advantage, like the regions that has maybe more likely to have a demand, price advantage where these innovations can be affordable, and there are some 2 other factors. So they identify these potential lead markets, and they put this innovation first there, and if it succeeds there, it will diffuse to others.
And I think just to that point, if you think of Facebook example, for example, when it was started by these 2 brothers and then it was taken by Mark Zuckerberg, so it was kind of in an interplay between, not although we can think of the ethical aspect. So there is also the regional, which is in Harvard, for example, where all of that started. It was started somewhere technically, but more deployed by a person who knew, for example, how to take it to the market. So probably more that the innovators have been maybe multiple people, and also like the regional aspect was extremely important, which was
The same with Steve Wozniak. we actually did everything.
About this, this also typical example of lead markets example, because that time when Facebook was established, launched, it was not the only social network. I was living in Germany, and there we had a much established social network, which I was using it. But then what happened is that since Ivy League universities has these lead market characteristics, this innovation took over because the late adopters, they don't want to follow an innovation that comes maybe from Germany, but they want to follow the innovation of a similar innovation that comes from a region that has lead market characteristics, such as Ivy League universities, because we perceive them.
Legitimacy, more legitimacy.
Yeah. Yeah. That's actually interesting, and we can talk about it later, about lead markets, which is one of my favorite topic to talk. Yeah. Do we have time? I don't know.
No, I think it's.
Yeah.
What do you think?
But we
Yeah,
can.
I think it's time to
Yeah.
wrap up.
We think we should wrap up.
Yes.
Okay. There's one question. But, I think
Yes,
we can
let's
take
take
it after maybe.
Yeah.
Yeah. So thank you so much, and you can always. Here is my information. You can call me. You can write me an email. And now I have a lot of time to also do different research projects and go to different empirical cases. Yeah, you're welcome to ask and collaborate. Thank you.
Thank you.